Okay, this is a short video on assignment number 2, specifically table 2, because that's the starting point of the assignment, and it may help you to understand what I mean in this table. You're given that you have a structure which is something like this. I don't know, something like that, and like that. And in one of the members you have strain gauge, and these strain gauge readings are given in 3 cycles PQR. So if you have an hour, so if you have a strain measurement, oops, let's get rid of this. If I get this pen, if you have, so you can have many cycles in an hour, and you're told that you have 80 cycles with a peak of 300, and 120 with a peak of 150, and a 600 with a peak of 90 in 8 hours. Okay, so that gives you the stress duty. But that's not really what I want to talk about today, because that's not too difficult to understand. What I want to tell you is how you convert the strain gauge reading into the value of the load at the end. This force can be upwards or downwards, because you don't know its direction. So upward is the positive direction here. So if it is downward, you have to enter here negative. So using the value of the P strain, you estimate the value of F. Now, I'm not going to solve it here for you, but I'm going to take a indicative example, I should say, that indicates that really probably will help you to understand how to convert strain into a force, including the direction. Let's say I have a situation like this with a cross section. Let's take this is let's say 10 millimeters square, just to make calculations easy. There is a unknown force acting here, which we don't know. To measure that force, we put a strain gauge on it. And on the strain gauge, let's say we read a P of 100 microsecond, 100 microstrains. So epsilon, so this is from 0 to 100. So epsilon is 100. So I'll probably solve it the way you should solve your assignment. So I'll say, okay, F, from F, if you say F is equal to 1 newtons, let's say assume F is equal to 1 newton acting in that direction. That's, or you can have it anything, you can have 10 newton, but let's say unit is good. So stress will be 1 newton over 10 millimeters square, which is 0.1 megapascals, and stress or strain is going to be equal to sigma over E. Let's say E is equal to 207, this for the sake of easy calculation, let's say 200,000 MPa. It's actually 207, but let's say it is 100 to make the calculation easy. That's not steel, some other material, 100,000 MPa. So epsilon is going to be 0.1 over 100,000. That's going to be 1, 2, 3, 4, 5, 10 to the minus 6. So if I had a force of 1 Newton acting in that direction, I would get an epsilon of 1 microstrain, or 10 to the minus 6. So that's for, this is for 1 microstrain, okay? So this one is for F is equal to 1 Newton. Where is what I measure? Let's say I measure here 100 in my strain gauge. So if epsilon is 100 times 10 to the minus 6, then what is the value of F that produces that? Obviously it will be the ratio between these two, so that will be 100 newtons. Okay, that's how you convert the strain gauge reading to a force. Now in this case it was very easy to calculate the strain on this member for a 1 Newton force in that direction. In your assignments, in your structure, it will be a bit more involved, but you can calculate the strain gauge on your structural member assigned to you. What will be the strain that should be experienced by that member, by the force, by 1 Newton? Then you know what your strain gauge reading is, so you can estimate the value of the F that should generate that strain. One thing you should be careful is the sign. For example, if I were all your strain, if your strain gauge is positive, okay? For example, suppose we have a situation like this. We have not like that. We have, I have a beam, and I am really interested in the value of F, and I have a strain gauge placed here. Let's say if the strain gauge reading was something like that, again from 0 to some value, but all from 0 going up. So what does tell me about the direction of F? Is F directed downwards as it says here? If it did, because for a downward force, the bending, because this thing is being bent, I would have compressive stress at the bottom. But if my strain, measured strain, is positive, not compression, but tension, so that means from here, you're saying that F is really not pointed downward, but pointed upwards, because a downward force would generate a negative strain. If I have a positive strain, my force is pointed upwards. Okay, so that's really how you calculate the magnitudes of the force F, because there are different F values to generate P and Q and R cycles. And that also, the way thinking like this, that also gives you its direction. Okay, that's all I have today. If I'm monitoring the discussion board to ask questions about assignment 2. If I feel that I need to give you more explanation through a video tutorial like this, I'll do that. But at the moment I have no plans to do so. Thank you.